All right, in this video, what I want to do is show you kind of a beginner way to approach this problem as well as an advanced expert way to approach this problem. Now, in reality, I don't think either approach is necessarily bad. It's just something I noticed once we get into division of polynomials. The kind of a beginner approach, most students just kind of focus in only on that. And then I also want you to remember, though, there is a more advanced, faster way to go ahead and complete the problem. So let's talk about the way that the most beginner students approach the division of two polynomials. When we're learning division of polynomials, first we talk about long division, then we get into synthetic division, and then it's like, stop, I know how to do synthetic division. That's what I'm going to do. It's the fastest, it's the easiest. Not always, but for majority of problems, we do like using synthetic division. So in this example, they say, well, I'm just going to go and do synthetic division. Okay, so let's go through that approach and see how bad this is. I mean, obviously, we're not dealing with huge polynomials here. We do have a divisor, which is a linear binomial, so we know we can apply synthetic division. We do have a coefficient, though, of our linear term, which is not ideal. But again, the main thing we want to do is first identify our k. So we're going to take our divisor, and we're going to set it equal to 0, and therefore x is equals to a -3/2. So that is going to be our k, which is going to be on the outside of our synthetic division bar. Now what we're going to do is take the coefficients of our dividend, and we're going to go ahead and write them inside of the box. Now we're just going to apply the synthetic division algorithm here. And first thing is we always bring down to 2. Bring down the first number first. And then remember, you multiply on the diagonal, add on the vertical. So 2 times -3/2 is a -3. -3 plus -3 is going to be a -6. -6 times a -3/2. Again, you could kind of think about this like over here. So -3/2 times a -6. You could put that over 1 times. That's nothing. So that'd be a +18 divided by 2, which is going to be a +9. Equals 0. So I got a remainder of 0, but it's important this is not my divisor, right? So whenever you're doing synthetic division and you have that coefficient of that linear term, you're going to have to divide everything by 2 again. So now I'm going to have a 1 and a -3. So that means my last factor is going to be an x -3. So again, it sometimes gets confusing when we're dealing with this, and that's why I kind of say it's like the beginner approach. So what would be this advanced approach, Mr. McLogan? If you were going to do this problem, what would you do? I would not do synthetic division. I would first look to see if this is factorable. It's a quadratic trinomial. Ladies and gentlemen, quadratic trinomials are the most often thing that we have to factor in and out every single day. Now, I understand once you see the number 2 in front of your quadratic term, you might shut down and say, I don't even want to try factoring this, right? But again, there's only so many options, guys. We have 9, which has factors of 9 and 1 and 3 and 3. So let's just try to see if this works. And also, here's the thing. We're trying to see if this is a potential factor. So why don't we do this? 2x plus 3 times what? It has to be x times what? All right, well, let's think about this, ladies and gentlemen. If 2x plus 3 is one of my factors, okay, 3 times what is going to give me -9? It has to be a -3. I have no other options, right? I know this has to be an x because 2x times x gives me 2x squared. So I know this has to be a -3. And then if I now I factored out my numerator, I have my denominator, boom. Therefore, I know this is my answer, x -3. So by just doing a little bit of knowledge of understanding, I could factor this, I could use this as a potential factor, and seeing if this works with the only option that was left, I was able to divide this much, much quicker than I would by using the synthetic division. Not always in every case, guys, are you going to have something that's factorable. Of course, you could do synthetic division and you're going to have you could have a remainder. So therefore, this approach would not work. But ladies and gentlemen, it took me 3 seconds to be able to figure this out. Something that you can do every single problem before you have to go to that synthetic division. Hope this helps.